Hello, everybody. This is Professor Jason Kim. Today, we're going to talk about the factoring special polynomials, okay, by using a concept a square minus b square equals product of or quantity of a plus b and a minus b formulas. So it's almost like formulas when something square minus another one square. So it has to be squared format, be able to change into squared format, and it has to be minus in between. Okay, let's say it's a first term and second term. Then the value of that becomes same as product of value of the first one plus second one with first one minus second one. First one means first term and second means second terms. So it's like rules, formulas that you have to memorize and recognize format of it. Again, difference between two perfect squares. So if you have that format, then it will become multiplication of quantity of addition and quantity of subtraction of two terms. Again, this rule, to utilize this rule, you have to have, first of all, is difference, subtraction, and squared format. So we call in general this as a difference of perfect squares. Okay, so here is a difference, and here's two perfect squared. Then it becomes product of sum and differences. So what does it mean? Perfect squares in numbers. Perfect squares perfect square numbers are like 1, because 1 times 1 is 1. 4 is a perfect square number because 2 times 2. 9 is a perfect square number because that's a 3 times 3. The same number squared, that's why they call perfect squared. So 16 is perfect squared number because it's 4 times 4. And 25 is next perfect square number. It's 5 times 5. 36 is a perfect squared number. So guess what would be the next perfect squared number? 7 times 7, which is 49. And 8 times 8, which is 64. 9 times 9, which is 81. And 10 times 10, which is 100. So those are the like 10 most common perfect square number. And at least like first 6, you have to memorize it. 1, 4, 9, 16, 25, 36. You really have to memorize it because we use this perfect squared or a multiple of those perfect squared a lot. Okay, so that's we call perfect squared numbers. Now then, what is a perfect squared variable? Perfect squared variables, variables are letters, right? Is anything that letter to the second power or a multiple of second power. So x squared is a perfect squared variable. X fourth is perfect squared variable because 4 is a multiple of 2. X6, x to the 6th power is perfect squared variable because 6 is a multiple of 2. X to the 8th is perfect squared variable because 8 is a multiple of 2. And x to the 10th and x to the 12th and on and on and on. So every, so to speak, even power is perfect squared variable because you can express in terms of a square or multiple of square. So x squared is actually x to the fourth power squared. X to the fourth is x to the second power to the second power. So you can express in perfect squared format. X to the sixth power is like x to the third to the square. X to the fourth, eighth power is x to the fourth to the square. X to the 10th power is x to the fifth to the square. So you are making something into square format. So in that way, you can apply this special polynomial rule or difference of a perfect squared rules. So every even power is perfect squared. So knowing these two, let's look at some examples. Example 1, simple difference of perfect squared case. Like number 1, they ask you to factor it. Okay, we learned about the factor in previous video, but this is a special case. So that's why we call this kind of polynomial as a special polynomial. Number 1, two rules to have a special polynomial or a difference of a perfect square. Number 1, it has to be minus between two things. Number 2, it has to be squared format with a minus. Okay, so let's see if we can make x squared minus 1 into squared format. Yes, this you can make x 1 to the square and 1 to the square. So then it becomes product of 1 for plus, 1 for minus. So first term was x, second term was 1. So you're adding and multiply with the quantity of x minus 1. So that's number 1. Does everybody follow this? How about number 2? When you have x squared minus 16, you can express this one into something square minus something square, right? Which is x squared minus 4 squared. Because if you have x squared minus 16, can you make this way? Yeah, x 1 to the square and 4 1 to the square. Okay, then it become a product of addition of two terms, first term and second term. You don't have to write a 1 because 1 power you don't write it. And second one is subtraction of x and 4. Okay, so you do that. Yeah. Now number 3, x squared minus y squared. You can make it as a x1 to the square minus y1 to the square. So x plus y times x minus y. Now a little more complicated one, 4x squared minus 49. Can you make this one as something square minus something square? Well, first term, 4 is 2 to the 1 squared, and x squared is x 1 to the square. And 49 is 7 1 to the square. Yes, we are able to successfully translate into something square minus something square format. So that become a product of plus 4 of two terms and minus of two terms. So 2x plus 7 with a 2x minus 7, like this. Okay. Now, when you have a 16, so that was number 4, right? So number 5, when you have a 16x squared minus 81y squared, can you make something square minus something square format? Yes, there will be 4x squared with a 9y individual squares. So that become 4x plus 9y times 4x minus 9y. Does this make sense? Okay. Now let's do some more exercise. Try this 4 questions and check your answer. And the bottom of this particular section. Okay. So this was the simple difference of a perfect square case. Now, next one is a more advanced format because they have greatest common factor. So in case there is a greatest common factor, then you always factor out the GCF first. That's the first thing you do. Okay. So this case, you scan it and see if there is a GCF, greatest common factors between two terms, then you take it out first before you do anything else. So let's look at step by step. So number 1, you have 18 a squared minus 8 b squares. So this one is difference between two terms and it has some squares. But this is not something square minus something square as it is, because 18 is not something square. So none of a square make 18 and none of a square make 8. So as of now, it's not directly can translate into something square minus something square. But one thing we found out was that you have GCF. So what was the GCF? Greatest common factor here. Well, every even numbers, 18 is even number and 8 is even number. So every time you have an even number, you always have at least minimum of GCF as a 2. Okay. Or you can do 18 and 8 and divide by 2. You got 2 goes to 18 9 times and 2 goes 4 times. And there is no more common factor in number, so 2 is a GCF. So that's another way of finding a GCF besides just guessing it. So whenever there is GCF, you take a GCF out and we divide each one by GCF. That's what we learned last video. And if you simplify it, you get 9a squared minus 4b squared. So you factored by GCF. So is this it? No. Now, not before, but now it look like you can translate it into difference of a perfect square in whole, individuals, I mean. So now you can write into this format. So what's going to be inside? Well, 9a squared means square of 3a. 9a squared, it means the square of 3a. And minus 4b squared is square of 2b's. So you have to look, see if you can be able to translate into a difference of square. Square of something, square of something. Square of first term minus square of second term. If you can do that, then it becomes a product addition of product of addition and subtraction of two terms. First term was 3a and 2b, and 3a minus 2b. And if you want, you can just get rid of the outside perimeter. So that's the step-by-step format. Now, if you look at the second one, 16x third minus 36xy square. Excuse me. So as of now, this one is not a format of something square minus something square as it is. It's not. Because you have a because you have a third power and you have one power here. But what we found out was you have a GCF. So GCF of 16x third and 36xy square, there is a GCF for number and GCF for the letter. So GCF become 4x. Can you see that? Yeah, 16 and 36. 16 and 36. 2 goes there 8 times. And 2 goes there 18 times. And 2 goes there 4 times, 9 times. And no more common factors, so 2 times 2 is 4. So that's how you find that 4. And you have an x in the first term and x in the second term. It says 4x. So what you do is you take a 4x out and divide individual term by 4x to simplify. Then you end up with a 4x with a 4x squared minus 9y squared. Now, not the outside, but now the inside is difference between two perfect square, the format that you can change into. So then it becomes 4x with something squared and something squared. Can you make it that way? Yeah. You can make it as, now I'm going to just get rid of outside one. 2x, square of 2x and square of, oh, I'm still putting the outside, okay. 3y. And that become addition and subtraction. So 2x plus 3y and 2x minus 3y. And you can just write without the outside parenthesis. As a final answer. So that's what this step in number 2 is. Now number 3, again, the first thing you do is, it is not perfect difference of a perfect squared format as it is. But what we found out was there is a GCF. So GCF of number 3 is 3AB. So take 3AB out, and if you simplify inside, you get 25B squared minus 4A squared. Now you can make this one into 3AB with something square minus something square. Yes, if you do that, the inside would be 5B and 2A squared of each. And then it becomes 3AB times first term plus second term, which is 5B plus 2A, and first term minus second term, 5B minus 2A. Okay? And number 4. 2 terms looks complicated. You cannot translate this into directly difference between 2 perfect square, but what I found out was there is a GCF, which is 7 and A and B. So take 7AB out, divide each one by 7AB, you end up with a squared minus 4b squared. Now, can you be able to make this one into something square minus something square, square of something format? Yes, the first one become a and second one become 2b. So now you write again 7ab with a plus 2b and a minus 2b. Okay, so these 4 questions are more advanced format. Can you see that? Yeah. So try exercise 2 and check your answer with the answer key at the end of this section. Now, third type of special polynomial is there is a multiple time difference of perfect square case. What does it mean multiple times? So when you have a question like x fourth minus y fourth, again, can you make this one into difference between two perfect square? Yes, this become x square square minus, oops, this is 4, y square square. So this particular question become product of first term plus second term multiplied by in quantity of first term minus second term. So we finished the perfect squared format into product of 2 in terms of quantity. But if you look your answer, the second one, minus 1, because this special polynomial only works with a minus between two perfect square, you realize that this is another difference between perfect square. So what does that mean? That means you have to do one more time. So after I write addition of two perfect square, now we have to write this one into something square minus something square format. Now, can you do that? Yeah, it's a x square plus y square with x square minus y squared format. Then it become product of one for addition and one for subtraction. First term was x and y and x and y. First term is x, second term is y. First term is x minus second term is y. So you don't stop here. You do one more time. That's what they are saying, multiple time difference of the perfect square. Okay? So whenever you see difference between two perfect square, you have to keep continue until there is no more. Okay? So second question, number 2, x fourth to 16 y fourth. Now, can you change this into something square minus something square? Yeah. Then inside it become x square square minus 16 fourth, xy to the fourth is 4y square square. Once you be able to do that, that's same as x square plus 4y square and then x square minus 4y square. Okay. So now you thought you finish the difference of perfect square, but as you see the second part, you can continue to do further because you still have a difference of perfect square. So can you change this into something square minus something square format on the second part? Yeah. So first part, you write as it is. But second one, you make it as x square minus 2y square. So now you are able to do that. Then you rewrite the first part and second part you do one more time. Okay. So x plus 2y and x minus 2y. So we call this kind of factoring, we say as a factor completely to the end. Okay. Now another example is when you have 81 a to the fourth minus 16b to the fourth. As you see, to recognize this is a multiple time difference, you always have like higher than second power, like fourth power. Okay. So that you are able to convert into 9a square minus 4b square. So that become 9a square plus 4b square with 9a square minus 4b squares. So we do plus first and do the minus second by the conveniency. And then the second part, you realize that you can do one more time. So that's 9a square plus 4b square with something square minus something square, which is 9a square plus 4b square with 3a whole thing square minus 2b whole thing squared. So don't make a mistake on here. Then you end up with 9a square 4b square with first term was 3a, second term was 2b, 3a plus 2b and 3a minus 2b as a factor completely. Now next question, when you have a to the eighth power minus b to the eighth power. You can change that into something square minus something square format, which is a to the fourth to the square and b to the fourth to the square. So that end up with the a to the fourth power plus b to the fourth power times a to the fourth power minus b to the fourth power. But as you see, the second one, you can do the difference of perfect square one more time. So that end up with a to the fourth plus b to the fourth with a square minus b square. Then this become a fourth plus b fourth with a square plus b square with a square minus b square. And again, you see this is another perfect square one more time here. So that become a to the fourth plus b to the fourth, a to the square b plus b to the square. And then it become something square minus something square, a and b. So you end up with a to the fourth plus b to the fourth, a to the square plus b to the square, a plus b, and a minus b in quantity. So that's how you get this. So it's many steps, but as long as you have a difference with perfect square, you have to keep doing it. Okay? So these are another exercise that you can try. Okay? And check with the answer key here. Okay, so this is a short video, but this is a video for the difference between perfect square when you have the condition to this kind of question is you have to have a minus in between two terms, and you have to be able to express in perfect square. So this is rather short video, but with very important topic. So making sure everybody study this. Okay. Have a good day.